All right, so breaking down how we're going to graph this parabola, I'm going to start by grouping my x's. I'm going to factor out this 2 so that I can complete the square. Got y equals 2 factored out, x squared minus 6x, leave some space to complete the square, plus 14. Now in completing the square, I'm going to take half of this negative 6, negative 3, square that, get 9. So adding on 9 here means I have to make an adjustment to the end part here of this function. Instead of adding 9 on, what I'm really doing is I'm adding on 18. And I know that because this 2 has to get multiplied to that 9 to give me that 18 value. So to balance things out, I'm going to subtract 18 out here. As I simplify things to my vertex form, I'm going to have y equals 2 times the quantity, the x minus 3 squared minus 4. Now, working off this vertex form, obviously I can find what the vertex is going to be. I know the vertex is going to be 3, negative 4. So I can plot that point. I also know, because this x portion is being squared, this is a parabola that must open up or down. I know it's opening up because of the positive 2, the positive a value in front. So the axis of symmetry has to run vertically through the vertex. And the axis of symmetry is going to be x equals 3. Next, I'm going to find a useful value that's going to give me a couple of things. I'm going to look at the value for what 1 over 4a equals. So I know a in my vertex form here is 2. 1 over 4a is going to be 1 over 4 times 2, or 1/8. What that 1/8 tells me, it tells me that from the vertex, since I know this is a parabola that will open upwards, if I go up 1/8 of a distance and plot a point, that's going to be my focal point for this parabola. So my focus is going to be the point where x is 3, and since I went up 1/8, I'll add that on to negative 4 here. That's going to give me negative 3 7/8 as the y coordinate at my focus. What this 1/8 also gives me, if I go 1/8 of a unit down from my vertex, it also gives me what is known as the directrix. The equation for this directrix is going to be y equals, I went down 1/8 of a distance from negative 4, so I could just say negative 4 1/8. So at this point, there's one more useful value for me to find to help me break down this parabola and get the most accurate sketch possible. That's the latus rectum. The latus rectum is found by taking the absolute value of 1 over whatever a is, and a was 2 in this case. So absolute value of 1/2 is going to be 1/2. What that represents the distance for a segment that is parallel to my directrix. And the focal point is going to be the midpoint of that segment. So if it's going to be the midpoint, and I know the total distance for the segment is 1/2, if I go out 1/4 the distance to each side to plot my endpoints of that segment, and draw my little segment in there, I know the distance of that segment is 1/2. These 2 points here and here will be points on my parabola. So knowing my vertex is right here, knowing I've got these 2 endpoints on the latus rectum right here, serving as points on the curve, I can sketch in a reasonable sketch of my parabola. So now that we've seen an example of how to sketch out all the details of parabola that opens either up or down, let's look at one that goes side to side. I know this one's going to go side to side because as I look at the y term here being squared, that tells me that this is going to be a left to right kind of opening parabola. So similar to the last one, I'm going to rearrange a few things first. This time I'm letting x equal, it'd be negative y squared plus 4y minus 1 as I bring the 1 over. I want to group my y's on this type of problem, and I want to factor out this negative 1 right here, giving me x equals the negative 1 in front, y squared minus 4y, leave some space so I can complete the square, minus 1. As I complete the square, I'm taking half of this negative 4, giving me negative 2, squaring that, so I'm adding 4. In reality, I'm really subtracting 4 because of this negative in front being multiplied to this 4. Since I'm subtracting 4 overall, I want to do the opposite out here, add 4 on to keep everything balanced. Now, as I factor down to my vertex form for this left to right opening graph, I've got a negative in front of the quantity, y minus 2 squared plus 3. Now, as I mentioned before, this is a left to right opening graph. I know because of this negative right here that the graph will open to the left. I also know that the vertex given to me by this form is going to be 3, 2. So I could go ahead and plot that point. Now, since this graph is going to be opening to the left or right, in this case I know it's opening to the left, the axis of symmetry is going to pass through the vertex in a horizontal manner. The axis of symmetry is going to be represented by the equation y equals 2. Just as I did on the last problem, I'm going to find a key value to work with. I'm going to look at that 1 over 4a value again. Here I know 1 over 4a is going to be 1 over the 4 times negative 1, so it's going to be negative 1/4. Now, just as it did on the last problem, this negative 1/4 is going to give me a couple of things. Like I did on the last problem, I'm going to start by noting what my focus is going to be. If I come over here to my vertex, that negative 1/4 is the distance that I'm going to travel back this direction along my axis of symmetry. Now, if I travel back that direction, negative 1/4 units, and plot a point, I've got my focal point, and I know the coordinates for that focal point. Well, let's see. I basically am moving back here off of my x value, which was 3. I'm going back a fourth, so I'm at 2 3/4 as my x coordinate, and the y value for the y coordinate remains the same. So there is my focal point ordered pair. Now, I also can figure out the directrix from this if I go back to the vertex and I go 1/4 the other direction. I draw in my directrix, and the equation for the directrix will be represented by x equals, since I moved 1/4 the distance this way, and I was at 3, I'm tacking on that 1/4, so I could say 3 1/4 would equal x for that equation. Only thing left to do now is consider the length of the lattice rectum, which would be the absolute value of 1 over a. So 1 over negative 1. If I take that absolute value, obviously I get 1 back. So the lattice rectum, as I mentioned on the last one, that's going to be the length of the segment that I can draw through the focus that is parallel to the directrix. The focus is going to serve as the midpoint of the lattice rectum. So since the length of the lattice rectum is 1, I'm going to go a half unit each direction. That way I ensure the total length is 1. I get 2 other key points here that are going to be on my parabola. I've got my vertex right here, also a key point on the parabola. If I want to sketch the curve in now, I can draw a pretty reasonable sketch of a parabola that is opening to the left.